The first thing we need to do is get our third person character. So there's two different ways. First, I'm going to show you how to add the third person character to an existing project. You're going to want to go here to add new, and then you're going to want to go to add feature content pack and third person, add to project. Now you should have the third person character here. There it is. And then to change your game mode character, you go here and change it to third person character. You're going to also want to delete the first person character, and there should be a spawn here, network player spawn. If not, you can search it here, player start. You just drag this out here. Go ahead and delete this network player start. So now when we hit play, we're starting as the third person character. So if you want to start a whole new third person project, you can do that as well. Click games, hit next, third person project, next. We'll call this third person parkour. Create project. That's loading up. This is the old project I have in the background. Here we are. So now in order to get the parkour component in here, you're going to have to migrate it from a different project. So go ahead and check the link in the description for the source code on this. You're going to want to get the source code for the parkour component, which is here. So now that you have the parkour movement in this project, you want to right click on it, click asset actions, migrate. And then you're going to want to verify that all the camera shakes and everything, the enum that you need, everything here should be good. Hit OK. So now I'm in the projects folder for the third person parkour project that I just made. And you're going to want to click on the content folder, hit select folder, and then it'll say content migration completed successfully. Now when we go back here, we'll see that we do have our parkour component right here. So those are two ways to get it into the project. We're going to need to make a few more adjustments here to get it to actually work. First, let's open the third person blueprint. And let's add a component. Let's add the parkour movement component. Compile that. Now we're going to want to hook up the events just like we did before. So grab the parkour movement component and do the jump event. We're also going to want to add the crouch event here. So in the last tutorial I showed you how to do the input actions. If you don't have that, it's alright, you can just use left control. Then you grab parkour movement, call crouch slide. Same thing for sprint. You might already have a sprint input event. If you do, use that or make one. If not, you can just use left shift. Grab the parkour movement component again and call the sprint event. Now we're going to want to hook into some events here. So right click and search for on movement mode changed. And also on landed. Grab the parkour component. We're going to call movement changed. And hook up the previous and new movement modes. We're also going to call the land event here. We're also going to want to initialize the parkour component. So go ahead and create the begin play node. Drag out the parkour movement and call initialize. And we'll also plug in our self for this. Compile. So as you see, it's now working with no animations. And there's a few things we have to do to get it working smoothly. One thing you'll notice is our character can act freely, kind of spin around while they're doing parkour modes, different parkour modes, and we're going to want to fix that. Also, crouch doesn't work, so we're going to want to implement that as well. So we'll do that next. All you need to do for crouch is go to your third person character, click on the character movement, component and search for crouch. I'm going to do can walk off ledges when crouching true and can crouch true. Compile that. Now you see the camera moving. Our capsule is also moving along with it, but of course we don't have a crouch animation, and I'll show you guys how to implement that later on. Another thing we're going to want to change in the character movement component is the crouched half height. For the animation we're using, a value of 70 more accurately represents what the animation is showing. Now if you find another crouch animation that has a lower value, you can go to the capsule collider here and do uncheck hidden in game so you can see it, and then you can figure out what the best value is for the crouched half height based on the animation you're using. Now before we get into the animations, there are some things we need to fix in the parkour movement component in order to get the character positioned correctly for the animations to look good. So let's open up the parkour movement component. It'll be in the content components folder. So what we're going to do is make a system where we move the character into position before they actually begin the parkour move. So let's go ahead and make variables for the target positions. We'll do a new variable. It'll be a vector and we'll call it vertical wall run target position. So this will store the position where we want our character to be, and we're going to want to do this for ledge climb and wall running too. So we'll start with ledge climbing. We'll do ledge floor target position. We're going to need this for later on when we're doing our ledge grabbing. We're going to want to know the position of the floor where we're actually grabbing the ledge. That way we can position it accordingly on the Z so the character is not too high or too low. Now let's do raw wall run target position. We're going to want the ledge, the actual wall vector for the ledge climb. So the wall target position and ledge climb wall target normal as well. We didn't need to make a normal vector for wall run or vertical wall run because we already have those values set. We're also going to make two bools. So the first one's going to be ledge close to ground. This is basically going to be if our character, we're going to detect if our character while ledge grabbing is very close to the ground. If he is, we're just going to do a quick mantle, because if not, then the character will fall, will go through the ground. So we don't want that. So that's what that bool is for. And the next one is going to be used later on. This one's going to be called default use controller rotation yaw. What this does is allow the character to spin around with the camera. So currently if I hit play, you'll see that doesn't happen. If we set that to true, the character would spin around with our camera. So that's going to be used later on when we implement the full body first person character. All right, now let's go to the wall run graph first. Now before I continue, there were some questions I got about enabling gravity after a set amount of time. So I'll go ahead and show you guys how to do that. If you're not interested, go ahead and skip ahead. I'll have timestamps below. So for those of you that are interested, let's create a new event and call it wall run enable gravity. Now keep in mind this variable we made before, wall run gravity, will no longer be set by us. It's going to be set programmatically. So whatever you do on here won't really have an effect. Now this custom event, all it's going to do is set wall run gravity to true if we are wall running. So let's go into our wall run update. Now let's make some room here. So we're going to make a branch. If our movement mode was set to true, this will only get called once because it can't be changed twice in a row. So right here is the perfect place to call our new function. So let's do a set timer by function name. Move this a little bit more. And our function name is going to be over here. Just grab this, paste it in here. This is going to be the time where the gravity starts to happen. So I'm going to set this to 1. You guys can set it to whatever you want, 1 second, 2, 3 seconds. Basically what will happen is the wall run gravity will be false, and then it will become true after this amount of time. Now you're going to want to do the same thing up here. So let's grab this. And if this was changed, go in here and then plug this into here. Now let's go to our wall run end event. And we're going to clear our timer by function name. We're going to clear the wall run, enable gravity. We're also going to want to reset the wall run gravity bool back to false, so that the next time we wall run, it'll be set to false. Next thing we're going to want to do is go to the wall run movement function, and we're going to want to make an update here. So it's going to be if wall run gravity is not true, or we're not wall running. So now if we test it, we should have it to where wall running starts off with no gravity, and then after 1 second we'll start to go down. It looks like it's working. Now the first thing we should fix is this rotation issue where it's like kind of rotating all the time freely. We're going to want to fix that so we can easily visualize where we need to position our character to correct it. So let's first go to the initialize function, initialize graph here. We'll grab our character and we'll grab our use controller rotation yaw. Set it to our default function here. Now let's go do the reset movement function. And in here, we're going to want to make some adjustments. So let's drag this out here. Now, if we're in none or crouch and we're trying to reset it, we're going to grab our character movement component and we'll set orient rotation to movement to true. And we'll also set the controller rotation yaw depending on what the default value is. So set use controller rotation yaw. We'll set that to whatever the default value is. There we are. Now, if we're not in some of these default states, then we're going to go ahead and lock our player so that they don't rotate around. So let's grab these two and put them down here. Make sure we have our targets set up. Now let's copy and paste that in here. So this is sprint is an exception case here. We do actually want the character to still rotate around freely while sprinting. We just don't want them to do that while they're like on a ledge or wall running or anything like that. So this is an exception. Then what we're going to want to do is add an and then plug in our use controller rotation yaw. And we'll plug that into here. So if the character's not sprinting, this is going to be set to false, meaning the character will no longer rotate around. They'll kind of be locked in place. And we're going to set the position correctly with the next segment. So now when I test it out, you should see the character, no matter what I do, he's kind of locked into position when he's hitting the wall. So now what we need to fix next is situations like these where you come at the wall at an angle that is not correct, and you see we're climbing up and we're kind of not really aligned with the wall. So we're gonna make those corrections next so that our animations look smooth and our characters aligned with the wall and everything else. All right, so we're gonna go ahead and create those correction functions now. Let's go back to our event graph and go into the wall run graph. All right, create a new custom event called correct wall run position. Now first we want to check to make sure that we are wall running, because if not, we won't have valid values, valid target values. So we'll check here for wall running. Now we're going to want to get our capsule component on the character. So let's go ahead and grab the character and grab the capsule component. And we're going to want to call a function called move component to. Now what this will do is exactly what it sounds like. It'll move our component exactly where we want it to go. Now the target relative location is going to be the wall run location offset off of the wall by our capsule radius. So let's go ahead and get our wall run target position. And we're going to add another vector to that. Let's get our capsule component again and get the unscaled capsule radius. And we can multiply this with our vector for the wall run normal. And then we can add these two vectors together, and that should be our target position. To make it cleaner, we can go ahead and collapse this and call it wall run target. Now we're going to do the same thing for the target relative rotation. So first let's make a rotator. Once again, we're going to want the capsule component, and we're going to get the relative rotation. Let's break this up. Since we don't want to edit the roll or pitch, we're only concerned about the yaw. So let's plug that in here, and then we'll make adjustments to the yaw by itself. So let's grab the wall run normal again. And we'll make a rotation from the X vector. Break this. And since it's not really the normal we want, but it's the cross product of the normal and Z, all we're going to want to do is subtract 90 degrees from our yaw. So let's do a select float here. And what we're going to check is if we're wall running left or right, because it'll be a different value depending on which kind of wall run we're doing. So we're going to get the current parkour mode, and we're going to check if we're on the left wall. If we are, we'll use 90 degrees. If not, we'll use negative 90 degrees. And then we can plug this into the yaw. So now let's go ahead and collapse this as well. And this will be a wall run, target rotation. Now to make it a little bit faster, we'll set this to 0.1. So now that we have this set up, we can go ahead and call this from within our wall run update function. So let's go ahead and go into there. If you skipped the part where we did the wall run gravity, all you need to do here is create these two branches that go off of the set parkour movement mode. And then on true, you're going to want to plug in both into the correct wall run position. And then you'll just skip this node if you're not interested in that. So now what this will do is The first time we set the parkour movement mode to one of the wall running variables, it's going to correct our position. Next, we need to go into our wall run movement and actually set our wall run position, the target position value. Let's go ahead and move these off to the side. And we're going to want to set our wall run target position. We'll set it to our impact point. Now, if I test it, you should see that it will actually rotate our character slightly so that it's aligned with the wall every time. This will make our animation work really nicely, and it won't matter what angle you come at the wall. It will always correct your position. Next, let's do vertical wall running and ledge climbing. We can actually go back to our wall run event and just copy what we did, because it's basically going to be the same thing. So we can just copy this whole thing, go into our vertical wall run, and we'll paste it in twice. So this one's going to be called correct vertical wall run position, and this one's going to be correct ledge climb position. And I'll just rename these, make it easier. Now we're not going to want to check if we're wall running, we're going to want to look at our current parkour mode. And for this one, we're going to want to verify that we are vertically wall running. And for this one, we're going to want to verify that we are ledge grabbing. Now first, let's go into our wall run target for vertical wall running. And we're just going to want to replace these two vectors. This is going to be the vertical wall run target position, and this one's going to be the vertical wall run normal. Now for our rotation function, same thing, we're going to change the wall run normal to the vertical wall run normal. Now instead of checking our wall running, we're going to want to do 180. So we subtract 180. Now let's go back and do the ledge grabbing. This one's a little more complicated, so we're going to want to make a vector here. And let's break this. Now our Z is going to be, we're going to be using our ledge floor target position for our Z. First, let's go ahead and replace these just like we did before. So wall climb, ledge climb, wall target normal, and then ledge climb, wall target position. Make sure these are correct. Now we're also going to want to get the unscaled capsule height, unscaled capsule half height, and we're going to want to grab the floor target position as well. And we're going to split this and subtract the half height from it. Plug that into our make vector. So now, similarly to before, we're going to position the character on the wall, and then the only difference here is that instead of using the same Z, we're going to use the Z of the floor that we're in, so that we're always positioned Z on the same, you know, kind of aligned with whatever we're grabbing onto. So let's go back and work on the rotation now. This one's simple. We're going to do the same thing as we did for the vertical wall run. We'll plug our ledge climb target normal into there, delete this, and subtract 180. There you go. Now let's go ahead and go into our vertical wall run update function. and make some adjustments here. We're going to use this and we're going to set our ledge floor target position to it. And then we can just use that here. Now let's go ahead and drag all this out because we're going to need to make a new function here. Let's go into our vertical wall run movement. And we're actually going to want to grab this and collapse this to a function. And we'll call this forward tracer. Now let's go back and we'll call this right here. Now we only want to proceed if we actually do hit the forward tracer. So let's move this out. We'll do an and check here with our hit. So if we do hit the wall and the surface is walkable, then that's when we'll want to proceed. Now let's go ahead and break this hit result so we can set our ledge climb wall vectors. So let's grab the ledge climb wall, the target position, and the target normal. Move this. So our target position is going to be the impact point. The target wall normal is going to be the impact normal. Now we're going to want to set our ledge close to ground bool here next. So let's go ahead and move this off to the side. We're going to want to do a new line trace by channel. Now the start position is going to be our character position. I get our actor location. And our end position is just going to be our location, and then just minus some value. So let's get our character's up vector. And we'll multiply it by some value. Plug that in. Now our value is going to be, just to make it more modular, it's going to be our capsule half height plus a certain buffer. So let's grab our character, get the capsule. Get our capsule half height. And offset that by value of 40. That seems to work pretty well. Now plug that in. So this is just going to check to make sure that we are ledge grabbing and we're not close to the ground. If not, we'll clip to the ground. We don't want that. So what we'll do here is set our ledge close to ground value to this here. Now with that, we're going to want to update our quick mantle bool to take that into account. So we're also going to do a check here. We're going to do an or. So either, our normal condition for quick mantling, or if the ledge is close to the ground, then we're going to do a quick mantle. Now, last thing we need to do here is correct our ledge location. So we can call that here. Compile that. Now let's go ahead and set up our vertical wall run movement. So let's go into here. Let's expand this, and we're also going to want to set our vertical wall run target position to the impact point. And let's go ahead and move this off to the side. And what we're going to want to do is add a branch here. And if this is true, so the first frame that we set the vertical wall run to true, we're going to correct the vertical wall run position and continue forward. If not, we're just going to launch the character. Next, let's go ahead and go to our vertical wall run end event. And we're gonna move these off to the side so that we can reset our ledge close to ground, set it back to false. I want to make a quick correction to the jump event, so let's go ahead and open that up before we proceed. So let's actually go ahead and collapse this to a function. Call it crouch jump. And plug this in here. Now in here, we actually don't want to call crouch slide event. We just want to call crouch end. So for crouching, it'll just call crouch end. So as you can see, no matter what angle I come at the wall, it will just correct the position and it will place myself at the same exact position every time so that the animation will look nice and clean. Same thing for wall climbing. So if I come at it at an angle, it'll rotate me. Next, we're going to want to import animations for all the different parkour modes, all the different moves. I got my animations from Mixamo. So you guys can go in here and, download whatever animations. If you don't like the one that I use, you can go in here and just grab whichever one you like. For the sake of this tutorial, I'm just going to refer you to the source file. You can go to my GitHub, and that's linked down below as well. And in here, you can download the entire Parkour project. You go here to code, and then download zip. Once you have the zip file downloaded, just extract it. And there we go. Now we have the extracted project file. Go in here, go to content, mannequin, animations, and we're just going to grab all these animations and paste it in here. We're going to skip whatever files we already have. And now we can close all this. Now here they are. We got all the animations we need. Next step's going to be to open the AnimBP, and we're going to set up the parkour graph. So first things first, just like in the first person BP, we're going to have to go to the event graph. And here we're going to do event begin play, blueprint begin play. We're going to do the same thing we did with the first person character. So we're going to get the parkour component, get component by class, and it's going to be the parkour component. And then we're going to check to see if it's valid. If it is, we're going to store a copy. And we'll call this parkour component. Now here in the update method, we're going to once again check to make sure that the parkour component is valid. And if it is, we're going to grab the current parkour mode, get current parkour mode, promote this to a variable, and this is going to be parkour mode. Now to make our lives a little bit easier, let's make a macro called is parkour mode. And in here, we're just going to compare the input, which is going to be a parkour mode, and we're going to compare it to see if it equals the current parkour mode. Mode. Now let's go back to the anim graph, and in here we're going to do blend poses by bool. Now we're going to get our is parkour mode and check to see if it's set to none. If it's set to none, we'll just do the default pose. But if it's not set to none, then we'll run a new state machine, which is going to be the Parkour state machine. So we'll call this Parkour. Now first we're going to want an idle state, so we can go back to the default state, just grab this, copy it, and paste it in here. So that's going to be our idle state. Then let's go ahead and create our state machines for everything else. So if we need a vertical wall run, quick mantle, we need ledge grab, we need mantle, slide, crouch, wall run left, wall run right, sprint. There you go. So let's just organize this a little bit. And let's go ahead and plug everything in. So we're going to want to go from idle to sprint, from sprint to idle, from wall run to idle, idle to wall run. Same for the wall run right. Also crouch, slide, ledge grab. And we're also going to want to connect ledge grab with mantle, and then mantle to idle. Quick mantle is going to be just in and out from idle. Same with vertical wall run. Now let's go ahead and add the animations one at a time. So for sprint, I just used the same third person run animation and just set the speed to 1.5. Wall run right, we're going to use wall run right. Wall run left, wall run left. For crouch, we're going to want to use a blend space, which we have right here. Crouch movement, plug that in, and then you're also going to want to plug in speed. So what this blend space is, it's just a blend between idle and walk and crouch. So that's good. Go back. Then we'll do slide. Now for this one, you're going to want to uncheck loop animation so it doesn't loop around. And then we'll go back. Ledge grab is going to be ledge hang. Now mantle is going to be our non-quick mantle, so it's going to be our ledge climb animation. And again, you're not going to want to loop this. We're also going to set the play rate to 2. Same thing for the quick mantle. So for this one, we'll use the mantle animation, set the play rate to 2, uncheck loop. There you go. Vertical wall run. It's going to be vertical wall run. And we'll set this speed to 2.5. Now we're going to want to set up all the different connections. So we'll start with this one since it's the most complicated one. The reason this is set up this way is because if we're grabbing onto a ledge and we transition to climbing over it, then we're going to want to do this mantle animation and not the quick mantle. So that's why it's set up this way. So for this one, we're going to go into here and we're going to use 2 of these parkour mode macros. First one, we're going to make sure that we're not ledge grabbing. So we're not ledge grabbing anymore. And then we're going to make sure that we are mantling. And if those 2 statements are true, then we'll go ahead and go into our ledge climb. So then we can go back, set these up. This one's simple. It's just going to be if we're not mantling anymore. And this one's going to be just if we are ledge grabbing. And we're only ever going to want to go back to idle from ledge grab if the user cancels, so if they don't mantle. So we're going to want to make sure that we're checking that. So if we're not ledge grabbing and we're not mantling, that's the only case where we will actually just drop off. Now that we have this section done, the rest are pretty simple. So for slide, for example, we're just going to do check the parkour mode, check if we're sliding. And then going back to idle, it's going to be the opposite, so we're not sliding. And you're just going to want to do the same thing for all the other ones. So it's going to be from idle to whatever parkour state, you're going to check that state. And then from the state back to idle, you're going to make sure that it's not that state. Now if you compile that and hit play, you should have all the animations now. I'm climbing up a wall, ledge grabbing, you can test sliding out and sprinting, and they're all there. Last thing I wanted to show you guys for the tutorial is how to make a full body first person character. So we're going to go into our third person blueprint. So the first thing we need to do is duplicate our third person character. So this is going to be our first person full body. Now we can go ahead and delete the third person character in the scene, and you go to world settings, change the game mode to the third person game mode, and then change the default pawn to our first person full body. Now we can open this up. So first thing we need to do is go to the root element here, and you see this little yellow undo on the controller rotation yaw. Go ahead and click that. Now what this does is it allows the camera to take control of the rotation in the yaw. Next we need to go ahead and move our camera boom here into the mesh. If we go to the viewport, we can kind of get a visual of what's going on here. So what we're going to want to do is change some settings here on the boom. So we need to change the target arm length. We'll set it to 10. Let's set the parent socket here to the head bone of our character. We can go ahead and reset this. And then we'll set this to 1 on the X and 20 on the Y. And we also need to reset the rotation. Now when we compile that, hit play, we should have a full body working now. We can slide. You want to get rid of that camera tilt, go back to our parkour component, go back to our camera tick function, and we need to find the slide node. We're going to delete this and drag it over to 0 to get rid of that camera tilt. So now when we slide, it doesn't tilt.